So my name is Kris Nova, and we're all here to learn about Kubernetes. And I'm going to learn a lot about you in a little bit, but we're going to talk about my personal favorite subject, myself, to start. OK, cool. So actually, before we get started, I always do this so that I remember. Who wants to be our timekeeper scrum master today? Volunteer right here. What's your name? Alex? OK. So if you want to set a timer or however you want to implement a solution to this problem here, at 3 p.m., we're going to take a break. We're going to start again at 3:10 p.m., and then we'll take another break at 4, and we'll come back here at 4:10 p.m. And then, like, literally wave your hands and yell, Nova, stop. We all have to go to the bathroom. Yep. It's the first homework assignment in the first, 5 seconds here. OK, cool. So just to give a little bit of background about me and to deformalize the situation, because this is a workshop, which means I hope people brought their laptops, because I'm going to be encouraging everyone here to jump into a terminal and actually install Kubernetes. And we're going to kind of go through this whole thing together. So I'm a Kubernetes maintainer. Last week was my 2-year anniversary of working on the Kubernetes project and being in the official org, whatever that means. So I work on a lot of software. If you're familiar with Kubernetes, you've probably ran some of my code. If you've ever played Pokemon Go or shopped at a Starbucks or used an Android phone or an iPhone, you're also running my code. I contribute to Golang sometimes, a lot of actual code contributions, and then just helping people with the programming language in general. Some notable projects that I've contributed to: Terraform. I'm a COPS maintainer. There's a project called oh, did my microphone go out? There's a project called Cuba Corn that is a reflection of me trying to get software engineers to talk about unicorns. So far, it's working really great. And also a program called KubeAdmin, and we're going to learn a lot more about those later. I'm an organizer of SIG AWS, which means I do a lot of Kubernetes on Amazon. The Kubernetes cluster I'll be spinning up today is on Amazon, but you're welcome to spin it up wherever you want, and we'll talk more about that later. I also am a member of SIG Cluster Lifecycle. That's another subgroup of Kubernetes, and our entire charter is to make installing Kubernetes easier and make managing Kubernetes easier. I wrote a book, more on that later. I climb mountains. Every one of my slides will have a picture of a mountain that I took. And also, I'm a cat lady, and all good technical presentations need some level of cats in them, so we're going to look at my cats in a second. Also, I'm transgender, and I don't know if you've been watching the news lately, but if you're not OK with this, you're not welcome here. Get out of the room. I'm serious. And also, if you want to take your phones out and tweet this so that everybody knows how realistic this is and how it's in your face, I would very much appreciate it, as would my family members and everybody who loves me. So there's that as well. OK, so all good technical presentations need a book. I remember going home and asking myself, damn, Nova, what's the best book you read last year? So I wrote this book called Cloud Native Infrastructure. And it talks a lot about cloud native infrastructure. And because I wrote it, I also read it. Anyway, if you want to check it out, it's going to be talking about a lot of the things in Kubernetes we're going to be going over today. So this is Mr. Darcy. He's my cat. He likes to sleep on cute things. And this is his sister, Kylie, who will literally draw blood from your legs at any moment. OK, so the goal for today: for you to be the Kubernetes gal or guy at your company, for you to be an expert. Who here runs Kubernetes right now? Who here, for some reason or another, thinks it's a really, really good idea to start running Kubernetes? OK, everybody put their hand up. OK, who can give me a reason? Volunteer. Come on, somebody, right here. What's a good reason to run Kubernetes?
Docker does not have the necessary infrastructure to scale up or down large projects.
Perfect. Docker does not have the necessary infrastructure to scale up or down. And there's a lot that's baked into that statement, even making the assumption that containers, which we're going to talk a little bit later, are also a good idea. Anyway, at the end of the presentation, or after our first break or our second break or whatever, we're going to come back, and I'm going to remind us of our goal so that when you walk out of here, you feel like you can pretty much answer any question about Kubernetes as it comes up and is needed. OK, cool. So what do you know about Kubernetes right now? Anybody? Container orchestration. Come on, more buzzwords. Hype, containers, throw it at me. Service discovery. What's another one? Configuration management. That's a good one. What was it? Agnostic to any cloud provider. That's super important. Cloud providers, Google, Amazon, Microsoft, DigitalOcean. Maybe you have your own cloud that you run in-house. How many people here run in a data center? 1, 2, 3, 4. How many people here are looking at running in the cloud, or that's why they're here today, is to learn more about moving to the cloud? OK. So I'm going to ask a lot of questions. I really want folks to participate, because, again, my job is to help you. So I'm not going to really get up here and lecture. I want to know what we're doing. So I'm actually looking at the answers. So please do put your hand up. OK, cool. So yeah, Kubernetes to me it's exciting. It solves a lot of problems. We're going to go into all of the nitty-gritty value adds and exactly what it is here in a moment. But for right now, I think the one sentiment I want folks to think of as we go through the presentation is Kubernetes is this new kernel. It's a layer of software that you build on top of. And because it's a layer of software, it just makes it easy for us as engineer-minded folks to interact with it in the same way that the kernel does. Also in the same way of the kernel, once certain features of Kubernetes are done, they're kind of done forever. And so we'll be looking at some of those specific features in a moment. OK, so to break everything down, here's what we're going to be going over today. Number one is just going to be getting started. So it's going to be getting Kubernetes up and running. Who here brought a laptop and is going to actually try to get Kubernetes up and running today? Awesome. And of those people, who thinks they're going to be able to do it on the first try? OK, and of those people, who has already tried to do this? Did you have fun? No? Yes? Mixed? It was OK? It wasn't too bad? OK. OK, so we're going to try to get a cluster up and running. We're going to talk about some of the ways that I like to get clusters up and running and some of the projects that I've worked on to help make that easier. And then we're going to look at actually creating a main function and putting that main function into a container. After that, we're going to have a break. We're going to come back, and we're going to learn a lot about the Kubernetes API objects and how we're going to take this container and run it in Kubernetes. That's going to take some time, and it's basically just going to be me and you hacking on Kubernetes together. I'll do some demos up here, and then we'll let folks try to kind of replicate that on their end. And then afterwards, we'll take a break. We'll come back, and we're going to talk about a public web service, actually getting some sort of resolvable URL up and running in Kubernetes. And we can even point that to a DNS record here live today, so folks can actually go and hit, I have a couple of DNS names we can use, and actually resolve a service that we're going to build together today. And then at the end, I have this sort of everything else slide. And this is nothing more than an amalgamation of all the questions I get asked all the time. So I'm assuming a lot of folks have those same questions, and we'll talk about that as well. OK, number one, getting started. OK, so let's talk about Kubernetes concretely. So this is the technical definition of what Kubernetes is, and not necessarily the value add of what you get from moving to Kubernetes. But this is important because we need to understand what needs to be installed before we actually go through the process of understanding a Kubernetes cluster. Also, these components are relevant as we start to look at building things out on top of them later. So the basic formula for Kubernetes, and honestly, this diagram is, you can't really find this anywhere, and I really like this because it's pretty simple. But to me, this is a good definition of what Kubernetes is and how it works. So over here, we have the internet. And this doesn't have to be the public internet. This would be any type of network where you and your team would access Kubernetes. So this could be the public internet. It could be your local office corp. It could be a hybrid of the two. It could be pretty much whatever you wanted it to be. From this network space, you then would have access to this API server. For all intents and purposes, think of the Kubernetes API server as the front gateway of how we're going to be interacting with Kubernetes. This is basically any old REST endpoint that you've interacted with before, but it's just specific to Kubernetes. Who here has written software up against an API before? OK, most people good. So I'm just ranting. OK, so the data store that we use in Kubernetes is called etcd. You'll be familiar with etcd as you look at the upgrade story, which we're going to talk about in a little bit because it's kind of annoying. But ultimately, what you need to know about it is it's a persistent data store. It stores key value pairs. And it allows for this really cool primitive called watch. And the API server watches the etcd data store. And because of this watch, the upper two components there, the scheduler and the controller manager, are able to respond to events in the data store. So this is, makes it a little bit different than like a traditional like MySQL database or something. Up at the top, we have this thing called the scheduler. Like literally, it's called the scheduler. And it's built off the same principles as the Linux process scheduler. Who here knows what the Linux process scheduler is? Who here has looked at the source code for that? Nice. Is it fun to look at that? It's not. So we kind of rewrote that and re-implemented some of the same principles, but it's written in Go. And all the scheduler does is it makes sense of what you tell the API server that gets stored in etcd, and then it tries to reason about the best way, given a certain policy, to schedule workloads for you. So it's just a layer of software that makes decisions. We then have this sort of action-oriented piece of software called the controller manager, which is a confusing way of saying it's a lot of controllers. Controllers are a special word in Kubernetes, and we have a whole like little mini lecture on them later. But basically, right now, all you need to know is a controller is the thing that does something. It might hit an API. It might interact with this other piece of software called the kubelet. But it takes some sort of action. And the controller is relatively dumb. In other words, the scheduler has all the smarts and makes all the decisions. And the controller basically just goes and implements those decisions and makes them so. The controllers are also important because they run in a loop. And that loop is sort of one of the big value adds in Kubernetes. And that loop is in a constant state of auditing what's in reality and then reconciling that state back and forth. A very simple example of a control loop is if we've all like done the robotics arm thing before. If I intended my arm to go down here, and then somebody came up and moved my arm, the robotics control loop would put it back where it needed to go, and that's where you get this motion from. The Kubernetes controller effectively does the same way. If you tell it to do 10 things, and then all of a sudden it audits the world and only 9 of those things are done, it will then try to redo that last one and reconcile that state to bring it back to 10. So that's what the controller does. And we're going to talk about how that actually matters later, but that's the broader pattern you need to be aware of. Everybody good so far? Any questions? Cool. OK, so the last piece I want to talk about is this thing called the kubelet. The kubelet is a Linux service that will run on a virtual machine. So you can literally jump on one of these virtual machines. It's a systemd service. You can go and look at the skeleton file, or not the skeleton file, the unit file. I'm still in init land, the best land. Anyway, the kubelets basically interact with the virtual machine and are the receiving end of what the controller manager is doing. So the controller manager might say, go do these 10 things, and it might distribute that across 3 or 4 different kubelets, 3, 3, and 4, or something like that. And ultimately, a kubelet's job is to run containers. That's really all it does. Now, running a container can mean a lot of things, but ultimately, the kubelet's going to make sure that container is running, and if for whatever reason the container breaks or something happens, it's going to try to restart it for us. In the same way that systemd will try to restart a service. And then we're left with these beautiful things at the end, which are containers running on virtual machines. So that's how you go from some client speaking to an API to some arbitrary mapping of containers to virtual machines. And those containers are what's going to run you and your team's application. Kubernetes just does all that for you. OK, so why do we care about all this? Why did I just spend like 5 minutes explaining the kubelet and the API server and everything? Because of this layer of software, we actually get a lot of value add with Kubernetes. The first thing I like to bring up is Kubernetes is complex. I'm going to try to kind of boil it down to raw ingredients for everyone today. But a lot of what I'm going to be talking about is going to be new, and it can be frustrating. I still get frustrated with Kubernetes, to be completely honest. Because of that complexity, these workshops exist, and frankly, that's why I have a job. But the thing you need to know about this complexity is the value add of you and your team moving to Kubernetes might outweigh this complexity. Another way of saying that is Kubernetes might be a technical investment for you and your team. In other words, it's going to be annoying. You're going to get frustrated. It's going to be new things. It's going to be like relearning Linux all over again. But once you get it, it's a lifetime skill, and you'll have it, and you and your team will have it. And the promise here is that because everyone's moving to it, if you move to it too, you'll be able to take advantage of a lot of the other work that other folks have done. So scalability, that word to me kind of pisses me off. I feel like a lot of people say it, and it doesn't really mean anything. But in Kubernetes, there's built-in scalability primitives, meaning almost every definition in Kubernetes has some sort of number attached to it, and that number represents an entity. We call those replica sets in Kubernetes, but the idea is that you could change the number 10 to the number 1,000, and then Kubernetes would kind of do the rest for you. So you don't really ever see an entity in Kubernetes that is just one thing. You see a lot of things that are called sets, and a set can be equal to 1, or it could be equal to 1,000,000. So that's when I say Kubernetes is scalable. I just mean that the software was built in with this mind of we're always going to have a list of things instead of just a thing. Kubernetes is repeatable. So a little bit about my background. I come in from no computer science degree whatsoever, although I've written a book that goes deep into computer science. I was an SRE and DevOps and a software engineer before I started doing the public speaking and working as a Kubernetes maintainer. But one of the things I learned was the importance of being able to repeat a problem. How many people here have had like it works for me, but it doesn't work for you problem? Everybody in the room just put their hand up for folks in the front row who didn't turn around. So yeah, Kubernetes aims to sort of solve this repeatability issue. And because it's repeatable, and because I can walk up to another software engineer in the field and be like, hey, run this command, and I would beyond the shadow of a doubt know you're going to like perfectly reenact the same thing that I enacted, it gives us a really strong foundation for doing like proper computer science. And when I say computer science, I literally mean experimenting with computers, right? Like I hypothesize this, and then like in my brain, I imagine like a whiteboard with a scientific method drawn out on it. And we can actually go and we can do things like, I'm going to introduce change and just see what happens. And as a team, we can sort of observe that and then do actual real experiments with our application, which is exciting. Also, because it's repeatable, that sort of gives us this ease of delivery for free. I walk up to another software engineer and I say, run this command. It's good for debugging, but it's even easier for the CI/CD team who needs to go and deliver our application for us. Another big feature of Kubernetes is this sort of resiliency and control and self-healing primitive. And that's what we get with these controllers. So we go into a working controller example later. But again, all you need to know for now is it's the robot arm thing, right? Like it audits the state, and then if that state changes, it puts it back. Which you don't really get with a lot of other tools. A lot of the other tools are kind of like throw it over the fence, call it good, and then you're done. So these are the big wins with Kubernetes. Does anybody have any other ones? Come on, somebody's got one. All you guys think it's a good idea to run Kubernetes, and you can't give me a value add? OK. What was that? Storing secrets. That's a great one. So Kubernetes has this built-in primitive for storing secrets so that you and your team don't really have to concern yourself with like hard coding sensitive information. You can sort of pass that off to a secret management team or department or somebody else. And then your application can just say, I would like a secret for this. And then it goes and gets that for you. So that's another value add for Kubernetes. And once we start actually getting it up and running, I think some of these wins will make sense. OK, let's talk about installing a cluster. So this is the part where it's going to get hands-on. I promise I'm only ranting for like the first 20 minutes of each little session here. OK, who here is going to move to GKE or Google? OK, we have a few hands. OK, so I'm just going to give like a high-level overview of all of the ways you can install a cluster. I'm not going to tell you how to install a cluster. But I will do probably a Cuba Corn and maybe a MiniCube demo up here on stage, depending on what people want. But I think it's important to call out the pros and cons of each one and kind of give a high-level overview of what Kubernetes does and the different people and ways you can install it. So GKE is a service provider. It's Google. They're the original gangsters of Kubernetes. This is the original Kubernetes as a service. This is the one that's been running longer than any other one. And this is where it all started. That started the whole Kubernetes thing. So they've been doing it. There's some concerns with it, but it's getting better. And for the most part, in my mind, it's probably the simplest solution. You can go and click a couple buttons and give them a credit card number, and poof, you get a Kubernetes cluster. A lot of people run on it. Pokemon Go. I play Pokemon Go with my girlfriend a lot, and I'm like, oh, I'm just test driving Kubernetes. It seems to be working great. So there's some good banter there. Upgrades work, but they're kind of magic. We're going to talk a little bit about upgrading a Kubernetes cluster later. But just all you need to know about GKE is they sort of solve that for you, and you don't really have to pay much attention to it. And last but not least, it's very reliable. Google in general just has excellent uptime, and there's a lot of case reports out there of folks running on GKE, and it's been working well for them. I don't even work for Google, so you're getting the unbiased overview here. EKS on AWS. This is important to me because I'm one of the organizers of SIG AWS. So if you're looking at running Kubernetes on Amazon, this might be exciting to you because this is Amazon's version of hosting Kubernetes, and you pay them, and they're going to solve the problem for you. It works pretty well. It's not quite as shiny as the rest of the Amazon services, but they're getting there. And then the whole thing is built sort of in an Amazon native way. So anytime they can take advantage of the other parts of AWS, they totally do. It does some pretty cool things with CNI that you can't get with other Kubernetes clusters. And it looks like my still not got cut off. Anyway, that was just still not as shiny as the other AWS objects. But it works pretty well. I used to work on the AKS team at Microsoft Azure before I worked for my new job at Heptio. If you want to run Kubernetes on Microsoft, it's Microsoft. Have fun. COPS on AWS. So this is the big one. If you want to run Kubernetes on Amazon, this is probably the best way to do it. I'm just going to be frank here. I'm a maintainer of this project, although I have a lot of grievances with the project now that I've been staring at the code for 2 years. But this is probably the best way to get up and off to the races. And it's going to give you the upgrade story that is a big problem. Again, that we'll go into detail later. So first off, you're welcome. It was a lot of work for us. Hats off to Justin, who's the primary contributor. He's done a ton of work. It's very proprietary, meaning once you get your cluster up and running, you're pretty much stuck using COPS. It's not super easy to migrate off of it. Also, it's pronounced COPS, by the way. It's not KOPS. You'll hear KOPS sometimes. But myself and Justin both call it COPS, and I feel like if we call it that, that makes it official, right? One of the things you need to be aware of with COPS, though, is it's falling behind. If you go to github.com/kubernetes/COPS, you'll see that we're on a version of Kubernetes that we support that is several versions behind the actual Kubernetes release. In other words, all of Kubernetes is running on version N, and COPS is N-2, is the most recent version you can install. So you don't even get all of the new goodies with COPS. And it's falling even further behind. So as the rest of Kubernetes continues to progress, COPS continues to sort of take our time, and we're falling further and further behind, partially because I am no longer really working on this project, and the trivia is Justin now does not work on Amazon. He works for Google now. So anyway, there is an amazing upgrade story, and a lot of the EKS stuff was sort of inspired by the COPS project. Heptio, the company I work for, we have this thing called the Heptio Quick Start. It's just CloudFormation for Amazon. I like it. It's my personal favorite AWS cluster to set up. But it is kind of a bit annoying because you're dealing with CloudFormation, and that's just always kind of a pain. So anyway, if you want to check that out as well. And again, all of these links are going to be, I'm going to have a thing you can take a picture of to get all these links, so don't worry about it right now. Cuba Corn. This is my personal favorite way of installing Kubernetes because there's rainbows and unicorns involved. And I solved a lot of the problems that frustrated me with COPS. I'm no longer really working on this because I'm working on this new thing that is complementary to some of the work we're doing at Heptio. But anyway, I'll be using Cuba Corn to spin up a cluster here today in a little bit. kubeadmin, so this is an exciting tool. So this is the official Kubernetes installation tool. This is built by the community, maintained by the community, and this is like the cream of the crop or whatever. The only problem is that this tool neglects to, well, I wouldn't say neglect, but intentionally doesn't solve the infrastructure problem. Meaning, it's not going to give you the virtual machine in Amazon. It's going to give you a command line tool that you can run on a virtual machine that you've already set up somehow, and it'll actually bootstrap Kubernetes for you. If you go back and you look at Cuba Corn, all Cuba Corn does is it wraps up kubeadmin, and then it also just builds the virtual machines and sets up the network and does everything else you need for you to get Kubernetes up and running. And so kubeadmin is just the tool that just does the software layer only. Excuse me. So this is what myself and Justin and a bunch of others are working on. Folks at Google have come together. Folks at Amazon have come together. The community has officially said, we're tired of this fragmented way of installing Kubernetes, and we're going to solve it all with this new thing called the Cluster API. And the Cluster API is going to basically wrap up kubeadmin in the same way Cuba Corn did, and create clusters for you on Amazon, Google, Azure, DigitalOcean, and even running in your own data center as soon as we get our first few releases out. So this is exciting, and if you want to learn more, feel free to ping me afterwards or come see one of my talks on the Cluster API, and I can tell you more about that. OK, so let's get a cluster up and running. If you would like to take a picture of this or type that into your URL, go for it. And that is a GitHub repository that I would encourage everyone here to feel free to open up pull requests to throughout the day. I put this thing together. I've used it a few times, but it's not perfect. And the whole point here is for this to be interactive. So if you can fix some documentation, if you want to add a new Docker file, whatever, feel free to open up a PR today. You don't even need to mention that you're doing it. Just open it up, and if I notice it, we'll look at it here on the screen. So yeah, let's take a look at this repo. Any questions so far before we actually try to get a Kubernetes cluster up and running? Yes, what's your question? Is there historical relevance to ECS? So it's relevant because it's a container orchestration tool which aims to solve the same problems of Kubernetes. I think, and a lot of folks agree with me on this, but I personally think that the Kubernetes solution is going to win and beat out ECS, particularly just because of the APIs alone. If we're all speaking the same language, then it makes it easier for us to build tooling to benefit the broader community. But ECS does the same thing as Kubernetes, but it doesn't go quite as far as Kubernetes. So somebody over here mentioned secret storage earlier. We don't get that in ECS. And there's a handful of other features that Kubernetes gives us that ECS does not as well. Yes, question? Yeah, so I think the question was Cluster API, is it related to OCI, the Open Container Interface? So they're kind of at different levels of this stack. OCI describes how you're going to make an image of a container effectively. The Cluster API is more of just a declarative way of managing the infrastructure of Kubernetes. So the Cluster API, in the same way that we talked about scalability earlier, changing a 10 to a 10,000, the Cluster API gives you that, but for virtual machines. Question? What's Knative? That's a really great question. I haven't even played with it yet. We do a thing every Friday called TGIK at Heptio, and it's either me or Joe. And if Joe does one, that's kind of my week off, so I kind of just completely ignore it that week. But I haven't played with it yet. But if anybody here wants to help our friend out, feel free. Any other questions? Going once, twice. We're about to set up a cluster, so.
So I've been getting Kubernetes set up using the Docker Edge channel.
OK.
And I was curious whether any of the methods you mentioned or are about to mention are better or worse than that. The only thing I noticed is that their version is a little bit behind. But I don't know if there are plans to stay in step with the official project to keep that going.
Sure.
I know it's Edge. There's no official support yet.
Totally. So I think Docker Edge is basically you come up here and you have Kubernetes right here. That's what you're talking about, right? OK, so I haven't actually used that yet. I remember I spoke with some folks at Docker and they told me they were building it in. But anytime you have any sort of installation tool, you're left with this dependency update problem. And this is starting to allude to the upgrade problem that I've been mentioning all day, which is how do you stay in sync? So I've never played with it. I can try to hack on it right now and set something up, and we can develop our opinions right now. But there is this handy dandy little Kubernetes thing you can check out here in the Docker drop-down menu for the Docker daemon. And then over here on the left, you'll see that we have a couple of different Kubernetes clusters. So we'll talk about the kube config and where that lives on your file system and how the Docker daemon is aware of those values. But those are all the different clusters I can authenticate with right now. Does that answer your question at all? Kind of, yeah. Any other questions? Yes?
You mentioned cluster API being a wrapper.
Yep.
Is it using Bosch or something as a VMware, as a VM creator?
It doesn't use Bosch. We're effectively building our own. So the way the project is set up is it describes the interface, like we have a machines primitive. And a machines primitive is agnostic if it's an EC2 instance, an Azure virtual machine, a Google virtual machine, whatever. And then there's specific cloud implementations that map this agnostic image to actually creating and destroying that infrastructure in a cloud. So the idea would be that we would have a different provider for each one of the clouds, and those providers just all speak a common denominator. Yep, and then all those proprietaries are homegrown and supported by the Kubernetes community. Any other questions? OK. Feel free to raise your hand if you have any questions as we go forward. So to start off, I'm going to use Cuba Corn here to get a cluster up and running. Somebody say when. Is that good? Can you see it? I can go bigger. Should I go bigger? Oh, hold on. Let me turn around. Oh, that is off screen. Here, I can fix this. I got this. And then I just won't go full screen, but I'll kind of like, there. That's big enough, right? We can all see that? Cool. OK, so if you want to download Cuba Corn and follow along with me, you can go to github.com/cubacorn/cubacorn. The problem is we don't have any static releases, so you're going to have to actually compile it yourself, which is why I'm also going to do a few other installation methods as well. This one is just relatively easy and follows COPS and just my preferred method, and I feel comfortable debugging it if something goes wrong, so that's why I'm going to set it up on my end. Also, right now, if you would like to explore GKE, EKS, or any other option on your own, we only have so much time today, so I'm not going to be able to go around and make sure every person sets their cluster up the same way. But if you would like to start trying to set up a Kubernetes cluster and you get stuck off in the weeds, now's the time, and I'm sure there's folks sitting near you who are also trying to go through it as well. So here is me using Cuba Corn, and then we'll do the Heptio quick start one as well. So I have the Cuba Corn binary installed on my computer. And it's just a basic, I can't even see my screen here. Hold on. There we go. It's just a basic command line tool. And you can see here we have create and delete, and there's a handful of other subcommands. So to create a cluster, I'm going to do Cuba Corn create. The name of my cluster, we'll call it Workshop 1. And profile, we're going to do AWS. And if we wanted to set it up in GKE, we would do that. And if we wanted to use DigitalOcean, we would do that. So for AWS, we're going to do that. It creates this YAML file, which is called the state of the cluster, which describes things like what port the API server is listening on, the size of the virtual machines. We don't really need to take a look at it because that's all changing to the cluster API. And then to apply that, I simply do Cuba Corn apply the name of our cluster. And I have environmental variables exported with my Amazon secret. And it's actually going and setting up infrastructure in Amazon for us. So let's go to my Amazon console, sign in. And if we go to EC2 here, we should be able to see a handful of instances starting to come up. So we have one running, and we should ultimately get, yeah, there should be two that are coming up now. So that's what's being set up in the background by Cuba Corn. So to go a little bit more granularly, let's go through the Heptio quick start together on your end as well. So this link should probably be here in the repo. I'm going to cheat and just add it. Cool. So if you want to refresh that on your end, you should now have the link. And we're going to be going through this together. So this describes what you're going to get. The big difference between Cuba Corn and the Heptio Quick Start is that we're going to be running the Quick Start virtual machines in a private subnet. So that introduces the need for this Bastion host here. So in order for us to SSH into our cluster, we would have to go through a Bastion. But that doesn't really matter, as we're only going to be interacting with Kubernetes through the API server for the most part of today's demo, which is publicly exposed. So I think we can do the deployment guide here. Nope, that's not what we want. How to deploy. Deploy into a new VPC. So we have our design template down here. It's automatically populated, so I think we can just go next. We'll give it a stack name. We'll call this Workshop 2. And then we have to define a few configuration bits down here. The admin ingress location. So I'm going to just YOLO, open that up. And I'm going to use my Knova SSH key. And just give all of this a quick overview. This all looks pretty solid. Yeah, that looks good to me. I need an IAM role. I might need to go create one of these. Let's do that here. Show of hands, who here is setting up using the Heptio Quick Start right now? Who here is doing GKE? Is anybody doing MiniCube? Would anybody like to see MiniCube? OK, we'll do MiniCube after this. Is there anything else anybody wants to see? Is that a question? Nope. OK, cool. If it is, just shout it out. Yo. Oh, sorry. I can do whatever. If you want it in a different form, I can get it to you in a different form. OK, yeah, totally. Yeah, just let me know, and I can maybe even do it here at the end. OK, so I need to set up an IAM role. So I'm setting up a new EC2 role, and I'm going to give that the administrator access policy just in the name of time, because we only have about 2 minutes before our next break. And I'm going to call it Kate's admin. Oh, I don't know why it kicked me out, but it did. OK, and over the break, I will do MiniCube so that we stay on topic. But I guess if folks want to take a break now or ask questions, go for it. We're about 2 minutes early, and it's just going to be setting up a cluster for the next probably 10 minutes or so. Or a question, yeah? It's going pretty fast. Can we slow it down? Sure. Is there anything in particular that I went fast on that you would like to see? Understood. Any other questions? Yeah, totally. So I will slow it down and be a little more concrete. If I start to go fast, just wave your hand and yell at me, OK? Any other questions? Great. So for the Heptio Quick Start, I'm giving it a stack name. For the availability zone, I'm just picking US West 2B. And for the admin ingress location, I'm opening it up to the world. And now I'm trying to figure out which type of IAM role I need to create for the Heptio quick start stack here. Timer? OK. All of these IAM roles do is just give our cloud formation that we're using in the Heptio quick start the ability to create infrastructure. It's just a security policy. It's just basic role authentication. OK, now that I've created that, I should be able to refresh this page, lose all of my work again. And define it here. OK, so now that we have that IAM role there, I can go ahead and click Next. And I'll click Create. And that should be coming up any moment now. OK, any questions on getting the Heptio quick start up and running? I know I went fast on that. Basically, I'm trying to demonstrate that getting Kubernetes up and running is a bit of a journey. And if I was to sit here and try to get everybody to do it in the same way, it would take a lot of time. So I'm trying to save folks a little bit of headache here and just get us to the point where we all have a cluster up and running. The reason for that is the whole promise of Kubernetes is it doesn't matter where you run it, right? OK, so we're waiting for that to spin up. We said we wanted to see MiniCube as well. So to do MiniCube, you can go to the official Kubernetes documentation. I just Googled for MiniCube. If you come here to the installation bit, you can see that there's this quick start for MiniCube. And if you click on installing it, this is really the page you want to go to. So I'll add this to the repository as well. Cool. So if you would like to go there and follow along, feel free to. So the first thing that we want to do is we want to make sure that we have a hypervisor installed. The reason that we need a hypervisor with MiniCube is the whole way that the cluster works is there's basically a community-provided virtual machine image that runs a Kubernetes cluster on a virtual machine on your local computer. So it doesn't actually run Kubernetes on your local host, your laptop here. It's actually going to spin up a virtual machine, and that virtual machine is going to have all of the Kubernetes components running inside of it. Because Kubernetes is scalable, you can technically run a full Kubernetes cluster on just one VM. You just install all of the software on one VM and point it to localhost instead of somewhere else on the network. So to install VirtualBox, you can go to the link here, and you can see that there's a VirtualBox download. For the OS X host, you want to click here. If you're running on Windows, there's a link there as well. And go ahead and download that, and you will get everything you need to run the virtual machine on your local computer. After that's installed, you're going to want to install this command line tool called, well, this is a great conversation to have. There's about 90 different ways to pronounce that. I personally say kubectl because I enjoy trolling people. But feel free to call it kubectl or kubecontrol or kubectl. You'll hear all of those used in the community around Kubernetes, and they're all referring to this tool here. And we're going to wait and install this until after our break because this is a really important part of Kubernetes. I'm sorry?
After you pull down VirtualBox, you need to put a VM on it?
Yep, that's this next step here where it says install MiniCube. Yep. It did work at one point. I think I remember somebody mentioning that it was either Xhive or Beehive was officially deprecated. But I think you can use pretty much any hypervisor. HyperKit? I don't know. Let's see. It looks like it's from Moby, which was once upon a time called Docker. So this looks like it's just another VM implementation from our friends at Docker. Cool. So we are, at this point, we're downloading our VirtualBox image here. I actually already have one installed, so I can just open that up here. And you'll see that I've actually already got a MiniCube image up and running, but we'll still go through the whole process. So MiniCube works from a command line tools perspective. So you would download the MiniCube command line tool, and then you actually use the command line tool to set up your virtual machine. It's actually remarkably easy. So to download MiniCube, you come here. In this case, I would download the MiniCube Darwin binary. If you're running on Linux, here's the Linux one. And it looks like we even have one for our friends running Windows as well. So download that. How to get to this page? Yep. So from this page, if you just click this latest release right here. Yep. And then that's just going to bring you to Kubernetes/MiniCube. Just an important bit of trivia here. If you look in the top left, you'll notice that it's Kubernetes. This tells us, just from looking at the page, this is an official community-supported project, meaning this isn't built by a company. It's built by several companies coming together to work and maintain this. The Kubernetes community in general, because of tools like this, is one of the big value adds of Kubernetes. The community built this, and because it uses the standardized API for everything, we get to take advantage of a lot of that for free. So anytime I can find a community-driven project like this, I usually opt into using them. So yeah, after you download the binary, I'm sorry? Yeah, just pick one that's right for you, for your architecture. So I downloaded the Darwin AMD 64 because I'm running a MacBook. Cool. After you get that running, actually, let me just do this. I can make that executable by doing a chmod plus x, the name of the binary here. And then I can move that into my path. User, local, bin, and then I'm just going to call it MiniCube. I already have one there, but I'm going to go ahead and replace it. So that's how you install MiniCube. And now, is everybody good? We good so far? Now, if you want to run it here, you totally can. There we go. And just like Cuba Corn, you'll see a lot of varieties. We have delete, and we have start, and we have stop. OK, so to start up a Kubernetes cluster with MiniCube, you type MiniCube start. And the command line tool is going to automatically detect VirtualBox. That's why I suggested we all use VirtualBox. And will download the image automatically for you from the community's repositories and actually magically start up this VirtualBox image here. And you can see now it says it's running, whereas a moment ago it was in I think a stopped state. So after this is done, we're going to take a look at the kubeconfig file once folks get back into the room. We'll give them another minute or so. Yes? Who's talking? Can you raise your hand? Oh, hi. What was your question? The Rancher's Kubernetes installer. So in general, the Rancher one, the Tectonic one, so these are companies that have they have a tool that solves this problem for you, right? It's like a paid service. You would call up Rancher and say, hey, I want to buy your service. And then you would have like a really shiny dashboard that allows you to set up Kubernetes at kind of the click of a button. So yeah, there's a lot of folks who are moving in that direction. That's, my opinion on it is like, it's just like moving to the cloud, right? Like if you want to throw money at the problem instead of solving it on your end, that's 10 out of 10 would recommend. It makes it easier. I don't want to plug my company because I am more interested in plugging the open source software, but there are companies, mine included, who do things like that and actually make that easier. If you're interested in talking more about that, I'm happy to kind of go off in the weeds. Technically speaking, I haven't really used the installer, but any installer, I would prefer them to use kubeadmin as the installation layer, which I know MiniCube does not use by default, although it does take a flag for you to use, just because that's the official way of starting Kubernetes, and I would like to see more people doing that. But yeah, there's a couple of solutions out there like that. Any other questions? Yes? I can't hear you at all, I'm sorry. Have I heard of the what? Can somebody help me? I can't hear that. RKE. I have not heard of RKE. What is RKE? Should I Google it? Oh, this is, looks like it's Rancher's thing. Rancher Kubernetes Engine, an extremely simple, lightweight, fast Kubernetes installer that works everywhere. Awesome. So yeah, earlier I mentioned if you want to open up a PR to the repository, I'm just trying to track these so the more workshops I do, folks get a better understanding. So that is, let's see, Heptio / Kubernetes Workshop. If you would like to add a snippet here in this file, feel free to PR that. If not, I'll add it afterwards as well. But it seems to be yet another Kubernetes installer. And I guess that's a really good segue into another lesson, which is there's a lot of Kubernetes installers. And that's one of the reasons why I didn't stand up here and say, go set it up this way, because I think it's important for folks to realize that there is no right way, there's just different ways. And there's pros and cons to each one. So the first takeaway from this is getting Kubernetes up and running is a pain in the ass, and you're going to have to develop your own opinions and figure out what makes sense for you and your team, just to be frank. Yep. OpenShift. Yeah, OpenShift, who here works for Red Hat? And yep. OK, so OpenShift is great. Red Hat is a huge community member in Kubernetes. But just like Rancher, it's another service provider, right? So it's another example of paying somebody to solve a lot of these problems and take away the sort of support burden that you and your team are going to have if you decide to start running Kubernetes. And what's really kind of great about all this is once all this is done and you kind of get the Kubernetes install done, Kubernetes is actually like really easy and a lot of fun. It's just kind of annoying to get here. But it's open source software, and that's where we are. But yeah, any other questions? And then we'll start back kind of with our lecture here in a moment. Yeah, question?
Looks like MiniCube uses kubeadm now.
Oh, it does by default?
And according to the help, like MiniCube start help or whatever says the default is now that.
OK, cool. So I guess there was a switch at some point. I'm not sure when that switch was. Last I checked, we weren't using it, so that's good to know as well. OK, cool. And then just to kind of give folks a high overview of the way this repo is set up, this is the link I shared earlier. We have this install markdown here, which feel free to add notes to that if there's notes that you think would benefit everyone else. And then we're going to move into this next section, main to a container. And we're going to go pretty slow through that because I feel like there's a lot to learn there in just a moment. And then I think we're going to have to wait on GKE until maybe after the session, if that's OK. Who asked for GKE? You did? If that's all right? OK. OK, so welcome back. We're going to kind of restart the lecture now. So just to give folks a quick overview of what we've done. I downloaded MiniCube and VirtualBox, and I ran MiniCube start, and that is bootstrapping now. I also did a Heptio quick start cluster. by going through this deploy into a new VPC link here. And there's a link in the repo here that the idea is this is the only link you're going to need for today. So we're going to keep piling links in here. So that quick start is up and running. And we can see that here for WK2. Although it looks like we might have ran into some issues. I think it maybe recreated it again. Let's actually go see what's going on here. OK, yeah. So I guess the Bastion was terminated for some reason. I might have to redeploy our Heptio quick start. It looks like we had some issues. This is one of the things with CloudFormation is just sometimes it just has bad weather, which is one of the reasons why I suggested to use Cuba Corn, which, to pat myself on the back, is up and working perfectly as expected. Go, Kris. OK. So let's go back into our slides now. Show of hands, who here has a cluster up and running already? Who here is on their way to getting a cluster up and running? OK. Should I wait to move forward, or should I go into the lecture now? I want to make sure I don't confuse people. Don't move forward? Yes, move forward? OK. OK. All right, so as our clusters come up, I'm going to just talk about what the first thing we're going to do in our cluster is after it gets up and running. So this should burn a couple more minutes. And then when that's all said and done, we should be able to actually run that against our clusters. I'll be able to do it here on my screen, and then hopefully you'll be able to replicate it on your end as well. OK. So this next section is we're going to go from a main function of any old program to a container. In the repository, I'll pull it up in a second, there's a directory called main to container. And I think there's 7 or 8 examples of like Java and Bash and Golang and Python. And if a programming language that you write is not in there, I would encourage you to open up a PR and create one, because it's pretty easy to do today. OK, so we're going to be creating a basic hello world program that all it does is it echoes out some text to standard out. And we can do that in virtually any programming language, as long as we can execute that code somehow inside of a container. And we'll need some sort of container image building tool. Some examples of these are probably the most common one to use is Docker. There's another one called Builda that is from our friends at Red Hat. Jesse has one called, I think it's pronounced image or img, but it's just img. This is another example, and you'll see this pattern in Kubernetes a lot, of more than one way to accomplish the same task. Today, we're going to be using Docker, simply because they're sort of the OGs here, and I feel like they have the best user experience for actually creating a container. And we'll talk about what a container and what an image is concretely in a moment. We'll also need a registry, which is basically going to serve as our artifact registry. Who here has used some type of registry before, like Artifactory or something else? OK, so you're familiar with this concept of creating something, a static binary perhaps, and pushing it up to some service, and then pulling down from that service as your point of distributing your application. So containers work in the exact same way. OK, the big question. What is a container? Who here wants to try to answer this question? Go. A process. I'm going to clap, because that's actually a really on-point explanation for what a container is. Containers they're definitely a new. Yep, so he said it looks like an operating system at a certain level. And I have a diagram that supports what he just said. So get rid of the idea that a container is a thing in your mind. There's no such thing as a container. It's ultimately just a system process. Who here has ever examined a system process before on a Unix-like operating system? So we're all familiar with things like it's going to get a PID. We can do a stack trace on it. We can send signals to it. This is just a regular old process. And there's a process scheduler on the system that actually starts this process. That's what a container is. It's just another system process. And so how I like to describe a container is this important business square is like your application, right? This is your main function. This is your program that can run in all of its programming goodness that makes you and your company lots of money. And that runs on some sort of computer. And that computer, your software has access to. And really, because that your program's running on a computer, it allows it to do all of the things it needs to do. It gives it memory to run with at runtime. It gives it network if it needs to make any HTTP or gRPC calls out to the broader internet. It's going to give it storage if it needs to like cat a file to disk or something like that. And it's going to give it all of these fundamentals that it needs to run. So from the context of your program, you can inspect the file system. You can write files to the file system. You can stick things in memory. You can do all of these things that we've been learning about in computer science. All a container does is it just draws an imaginary box around this program. So in this diagram, let's just take a very simple, concrete example. In this situation, let's say that we told the container to only allocate 5 gigabytes of space for that container. So if your application looked onto the underlying file system, it would see that there is one 5 gigabyte volume. And if we were running without a container, it would actually see the true volume size that the rest of the computer runs on, let's say 20 gigabytes. So in this example, your program would be able to run with 20 gigabytes of storage. And in this example, we've contained that program and only told it that it can use this imaginary volume that's only 5 gigabytes. And that's all the program can see. And because of that, we now know that we can't actually max out our disks on this broader computer here. So all containers do is it synthesizes a computer around your program. And it does that in the context of glorifying a system process. So I'll get off kind of deep here for folks who are interested. But if this is above your head, it's OK. You don't need to know this. How containers work are they're taking advantage of these two really important features that came into the Linux kernel recently. One of them is called C groups, and another one is called namespace isolation. Those two things allow software engineers to cleverly draw imaginary boundaries around a process. Because of those kernel features, we now have containers. If that doesn't make sense to you, all you need to know is it's a process, and you can tell it how much memory, how much computer, and how much disk space it has attached to it. Also, with container networking, you realize that we have two networks that we've now created. We have the host network, which is just the regular old computer network. And then we also have the container network as well. And there's some sort of bridging that can happen between the two of these. In other words, we can map port 8080 on our host computer to port 80 on our container. And if we want to allow traffic into and out of our container, we need to explicitly define those rules as well. So this is all fine and good, and we understand that containers are a new way of glorifying system processes. But we need to talk about this registry thing again, and then we'll actually go through and build a container. So a container image, and I wish I had a diagram for this, is basically a snapshot of one of these system processes. And from a container image, I can rerun that on any computer that can run containers. So this sort of solves the it works for me but not for you problem, because I can package up a full operating system, all of the disk space I need, all of the networking rules I need, and my application into one logical entity, take a snapshot of it, and go stick it up into a repository called a registry. And then I can pull that image down and recreate it whenever I need to again. So we're actually going to do that right now while we're waiting for our Kubernetes clusters to come up. So if you go into the repository and you come here into this main to container directory, you'll see that we have all of these examples of different ways we can actually go and build a container. How are we doing on time? Wow, this is going fast. OK. Who here sees a programming language that they're going to use? Who here wants a programming language that's not in there? What is it? Node.js. would you be interested in building a Node.js container with us as we move forward? OK. I'll kind of pick on you a little bit. Any other ones? You now know. What is this, yours? OK, cool. Do you mind opening up a PR along the way if you get it up in there? OK, cool. So yeah, hopefully we'll see a Node.js pull request, and we'll see whichever Ian has. I don't even know what language that was. Any suggestions on which one I should use to be helpful? Python? Does everybody like Python? It seems to be like a kind of a lowest common denominator. OK, Python it is. OK, so in our Python directory, we will see we have 3 files. Who here has never looked at a makefile before? Nobody? We're all familiar with make. So if I pull up a makefile, everybody's going to understand that? OK, cool. Who here has never looked at a Docker file before? OK. We'll start with the Python. The world's simplest Python program. So down on lines 8 and 9, we have this really familiar if name is equal to main. We're going to execute this function called run. If we look at run, it just says print rock climbing is the best sport in the world. And then it's going to sleep for 1,000 seconds, and then the program exits. And then on line 1, you can see that we import the module time. I think I said that right. I think they're called modules in Python. So pretty much all of the programs in all of the examples here fit this mold. They echo out some text, and then they sleep, and then they exit. And all we're going to do is we're going to take this Python program that you could run directly with Python, and we're going to shove it all into a container with things like the Python executor, a small amount of disk space attached to it, and the program itself. So how we do that is we have these primitives in the make file that are then going to read the Docker file using a command line tool called Docker to actually create our container for us. And so to examine the Docker file and kind of explain what this is also a very simple example. And if you go and you see Docker files in the wild, you'll see that they get very long and they can be very confusing. I think this is a really great way to start. This is a very simple example, and it gives you everything you need to get off to the races. So on line 1, we see this from keyword. And then we say Python latest. So what's happening there is we're telling Docker in this file that we would like to create a new container, and we want to create that container based on a previous existing image. And what image we've chosen is this one called Python. So if you go to Google and you just type Python Docker container, you'll actually see that hub.docker.com has this thing called library, and there is an official Docker Hub Python container. Now this has a set of maintainers that actually maintain these containers, and they'll actually go and build it for you. The sort of promise here is that this container already ships with Python installed. So think of this as like a basic Ubuntu server that just has Python, and you can execute Python commands on it. That's really what this image starts out as. And you'll see that there are images for Java, there's images for Ruby, there's images for Golang. We even have images for certain programs like Nginx or MongoDB. And all you have to do to run these is just pull the Docker image. So we could have created our own registry here, and we could have explicitly typed out an HTTP URL here. But instead, we just did the shorthand, and Docker is smart enough to say, oh, if you just type the word Python, I'm just going to look at the Docker Hub official registry and just pull the Python container as well. But there is some syntax here for actually building your own containers and running them later. So the next thing we do is we do this add keyword. And what this line says is it says add the directory that this is in and mount that in the container into /app. So we'll actually build this container and look inside of it and actually see that there is a directory in root called app. And then it also says workdir in /app. That basically says whenever you access the container, it's going to start you in the /app directory. And last but not least, we define this list of strings called command. And this is verbatim what you would actually type inside the container to actually execute our program. So here we just simply say Python, that we know is already installed, and we say main.py, which of course is this main.py file we looked at. And the make file here just takes all of these Docker commands that I'm about to go through and just bundles them up and simplifies it for us. OK. Looks like we had an error with MiniCube. Let's try. Oh, let's just try this again really quick. Looks like all of my things timed out. OK, well, we can get cube configs in a moment. I think I just had a hiccup in my internet or something. So I have the repository checked out here in my Go path on my computer, just because I write a lot of Go. Heptio / Kubernetes Workshop. And then we want to go into the main to container directory, and then we want to go into Python here. OK. So here's our Docker file, our make file, and our main.py. So I can run this file locally and just run python main.py, and you can see that rock climbing is the best sport in the world, and then I sent sig term or Control-C to exit the program, because it was going to sleep for 1,000 seconds. In order for us to build a container, we can actually cheat and look at the make file and see what the make file is doing. So if I was to type make container, you would see that it says docker build -t, and then it just populates the next command with some variables that are defined up here at the top. So in Docker Hub, I have a user named Kris Nova. So if I go to Docker Hub, hub.docker.com/Kris Nova, let me sign in. There we go. You can see all of my containers that I've built are here. And you can go to this URL on your end and actually access my containers. So if you want to go and create a Docker Hub user account and use this as your registry, you're welcome to. And I have a slide in a moment I'll pull up that highlights a few other registry choices for you and your team. But anyway, I just wanted you to know this is where I'll be pushing mine today. So in order for us to build our container, I'm just going to actually type this out explicitly so you can see the command. Docker build -t. The name of our registry, which is Kris Nova, then a /, and we want to call this Kubernetes Workshop app, which this can be any name you want. You can call this whatever you want. And then we're going to tell it to build the tag latest. And then we want to build that in our local directory, so I just add a period to the end there. And if I run this, because I have Docker and the Docker daemon installed up here, you can see that it's going and it's doing some magic for us behind the scenes. OK, so what just happened? So Docker said it read that Docker file, and it put all this stuff together for us. And because I had a Docker file that made sense, I was able to actually go and build this container. And if we go and we look at the logs, we can actually see what it was doing. So it says step 1 of 4. From Python latest. So it read that first line first. It runs procedurally, just like an interpreted scripting language. And it says pulling from library Python. And then it noticed that most of the container was there. The way containers work is they're all built on file systems, and some of those file systems don't ever change. So this, to me, looks like there was just a small update in the Python container. And this is the bit that changed, and this is the bit that remained the same. So it pulled the new changes in, and it said, here's a unique SHA for the version of that container that I'm running. And it says, OK, I've downloaded this new Python image, and we're up to date with whatever the community has blessed as the official Python image. I'm sure there was some patch or some security vulnerability that they had to fix. And if I wanted to go and look at the history there, I certainly could. The reason that it pulled this updated change just now is because I said from Python latest. If I didn't do latest, I could do a specific number or specific release of the Python container, which are all mapped out at hub.docker.com/Python. So I could have done 3.7.0 stretch, which would be Python version 3.7. And I could have defined any of these for the tag. If you just do latest, you're always just going to get whatever is on the most recent version. So there's pros and cons to doing latest, such as you can blindly download patches like we just did and not know what's in them. OK, so back in our terminal, we then add the local directory to /app. We set our workdir to /app. And it told it, by default, run python main.py. So let's go ahead and let's run this container. So I can do docker run the name of our container, which I'll just copy right here. Why is it not echoing out rock climbing is the best sport in the world? OK, there it did. OK, so the way that it worked was until the program exited, it wasn't actually going to relay the standard out back to the screen. But because I sent a sig term, because I didn't want to wait for the sleep for 1,000 seconds, I killed the program. And then it echoed it out, and then it terminated the program. So that was the behavior that we just saw there. So that was a Docker run, and it was running our Python app. So let's actually go and inspect this container. Let's see what's going on inside this container. So in order to do that, I can do a Docker run, but I'm going to add the IT argument here, which stands for interactive TTY. I'm going to paste the name of our container again, which is Kris Nova Kubernetes Workshop app. And then at the end, there's this optional argument where I'm just going to type bash. And what that bash does is it overrides this line here. So instead of running Python main.py in a container, I'm actually just going to start a bash shell so that I can actually go and explore the container and see what it looks like. So if I run that, you can see I've actually started a new TTY. Oh, I'm like off the screen. Sorry, I didn't realize. What I see here and here is different than what's up there. So that's kind of annoying. OK, that's a little bit better. You can see here I've actually started this new root at the name of the container. And you can see that I've started in the /app directory. And if I do an ls here, you can see that I now have the Docker file, the make file, and the main.py file just from this line here where we added the local print working directory to /app. And if I actually do the Python run main.py, did I type that wrong? Oh, Python run. Oh my gosh, thank you. Python, yeah, there we go. Rock climbing is the best sport in the world. And we can kill it. What's interesting, though, is I still have all of the Linux primitives that I would have otherwise, right? So I can actually go and actually see what this container looks like. And you'll actually see that this container is actually different than my host file system. So that's one of the benefits of a container is I'm able to bundle up basically a working magic little space for you and your application. And we'll run that in a moment as well. And this is the whole value add for Kubernetes. And all Kubernetes does is it makes what I'm doing right now easy. And we're going to get to the Kubernetes stuff in a moment, I promise. OK, so that's our Python application. Any questions so far on building the container or accessing the container or why containers are even a thing right now? Any questions at all? Yes? Yep. The question was, which line in the code copied these files? So that's line 3 right here. Add this period is just shorthand for the directory that we're in. And we're going to add that to /app. Yes, question? The difference between add and copy is we're effectively creating a reference in one, and we're creating a copy in the other. Copy copies it, and add adds the reference. So with add, I would be able to make changes within the. I almost always do add, although if I really want to make sure I have an immutable copy, I'll do copy. If you aren't sure which one to use, start with add until you have a reason not to. That's what I like to tell folks. Question?
The variables in your make file, registry, and image, that's just your Docker Hub username and repo?
Yep. So the question was the variables in my make file. So I have my make file here. The top registry is your Docker Hub username, which is also the name of your Docker Hub. Instead of saying Kris Nova by itself, I could actually do https:// Google has one called GCR, and that's gcr.io. Amazon has one called ECR. Quay from our friends at CoreOS have one. And you could actually put that in there. But because we're using Docker Hub, I don't have to put that HTTP nonsense, so I just put my username, which is Kris Nova. And then for image, this can be whatever you want to call your image. And then the tag, of course, is whatever you want to tag it as. I'm doing latest just to demonstrate how we can sort of do the CI/CD thing with Kubernetes moving forward. So anyway, if we look at push here, all it does is it say docker push, and then remember this just equates to the name of our image, the sort of full name of our image. So I'm going to just actually type that out here and do docker push. Do I still have? Nope, I don't have it. Let's see if we can find the name of our image here. So docker push, the name of our image. I've already done a Docker login and authenticated with Docker Hub, and so now it's just pushing my image up to Docker Hub. OK, so I got a unique SHA for that that is specific to this one-time artifact. And if I actually go to the Kris Nova Docker Hub here, we can look for Kubernetes Workshop app. And you can see under tags, did I push that correctly? Kubernetes Workshop app. Ah, thank you. That should do it. I forgot to add the tag to the end of my Docker push. OK, so now if I refresh this, what? It should still say updated. I don't know. There might be something going on with, I don't know why it's not showing that it updated right now. That's really weird. OK, so anyway, moving forward. So we've now pushed our container up to Kris Nova Kubernetes Workshop app latest. And so if you, on your system, wanted to do a type this command, docker run, and if somebody could do this, would actually be helpful, docker run the name of our the image I just pushed latest, you should actually be able to run the Python program I just built on my computer on your computer. Can anybody type this out and run this for me really quick? Anybody? Any volunteers? OK, we have one up here, right here. All I'm looking for is, yes, the rock climbing is the best sport in the world, text echoed out, just to sanity check that the Docker registry is actually working. Sorry, who's talking? I can't see. Oh, OK, so you have to control C or it's still going to wait. Is that what you're saying? Yeah, I mean, that's the behavior we're hoping to see. But I'm just wanting to see if somebody else can replicate it. Has anybody been able to run the docker run command?
It's still pulling.
OK, still pulling. Conference Wi-Fi. So after we can guarantee that we can actually pull this container down and run it on a different system, we've now demonstrated that we're able to do what the bare minimum requirements for Kubernetes needs to actually run this container in Kubernetes. OK, I'm going to jump back into some slides really quick, and then we'll take a break. And then after that break, we're actually going to run this in Kubernetes. Phil, you got it? You did a Docker run, and you got rock climbing as the best sport in the world? Thank you. Thank you. So I don't know. That's weird. I've never seen these tags. Oh, now, of course, it works now. It says updated 2 minutes ago. Very weird. Must be a caching issue on my end. OK, thanks for helping me there, Phil. OK, so that's building a Docker container image. Let's look at these slides. OK, so to review, we should now have a Kubernetes cluster up and running. And we should be able to build a simple hello world application in a programming language of your choice and push that up to a registry. So that's where we should be right now. We're going to skip that break. And let's actually talk about, actually, no, let's do that. Let's take a break, because when we get back, we're going to jump into Kubernetes pretty hard. So another 10-minute break, and then we'll start the actually running in Kubernetes bit. Cool. Absolutely. So the question was basically, what is the resource of Kubernetes? Where can I stay up to speed? Honestly, That's a really good question. So, okay, I'll answer how I do it, and then I'll answer how that's probably not going to work for anyone else but me. And then I'll give you a few ideas that I have off the top of my head. So I don't really have the problem of needing to stay up to speed with Kubernetes. As one of my other fellow maintainers here, Phil, can tell you, we are constantly bombarded with updates from the mailing list that comes in from Kubernetes. So it's almost at the point where I hear too much about it from the official Kubernetes mailing list, probably. But as a consumer, you're probably interested in, like, what's the latest release? What is in that release? Why do I care about it? And maybe some, like, opinionated, like, fluff on top that says if we like it or if we don't like it, right? So my company, Heptio, is trying to get better at, like, offering a release sort of overview where we talk about it every release cycle. I guess just in general, it's important to note, Kubernetes releases extremely fast. Right now, we're on about every 3 months, we cut a new release. For an open source project, that's pretty fast. And because of that speed, that's where the upgrade problem comes in. So there is the Kubernetes documentation, which is kubernetes.io here. And this is a good resource for how to run Kubernetes and stays up to date. If you actually go to the GitHub repo, github.com/kubernetes/kubernetes, you can click on releases, and this is where you can actually get the authentic, like, ironclad Kubernetes release with the release notes here in these change logs, for instance. And you'll notice that you'll see a lot of different versions, like we just cut 1.10.9, and we're also in 1.13 alpha. God, I can't believe we're already on 1.13. 1.13 is the newest release that's about to come out. And then we just dropped 1.12, as they would say in the community. And you can come in and actually click on the changelog here. And the changelog is all built from down here, other notable changes. This is all built from various commits to the actual code itself. So this is a good resource if you wanted to go to the Kubernetes repo. Also, if you're getting into Kubernetes, just so that you don't feel unwelcome, a lot of folks refer to this repository as k/k or kk. It just means Kubernetes/Kubernetes. And then this repo is sort of like where it all started. This is like the beginning of Kubernetes here. And this is a great example of how you should never structure a repository. And I'm really opinionated because I used to work out of this thing a lot. But if you come here to command, you'll see these are all independent executables that all are built out of this same repository, all of which use some version of other packages that are also found in this repository as well. So keeping up with it is quite annoying because there's pull requests that come in for the kubeadmin that have nothing to do with any of these other projects. And if you actually go into the, oh my God, we're less than 1,000. So we are actually doing really good right now. If you come into the pull requests here, you can actually see all the different PRs that are coming into Kubernetes. And we're in the process of pulling the repo apart as well. So you'll now see we have Kubernetes SIGs organization here. And then here in the Kubernetes SIGs, we have all of these projects that are official Kubernetes projects that are just maintained by Kubernetes versions of subsystems that we call SIGs. And a SIG just focuses on one specific thing. There's SIG networking that focuses on networking. There's SIG AWS that focuses on Kubernetes on Amazon. And then each of those groups of people can have projects here as well. So that's kind of how the Kubernetes ecosystem is set up. Yep. Any other questions? Awesome. OK, let's get started with some slides. And we have about an hour left, so we're going to go pretty quick here. So as we look at actually deploying to Kubernetes, there's yet another, and I told you would see this pattern. There's yet another set of tools you can choose from to deploy a container that we just created to Kubernetes. The main ones that you'll see if you start Googling around for deploying my app to Kubernetes or looking at tutorials are Helm, Ksonnet, and Kubectl. Helm is a tool that's basically, well, actually, we're going to go into them in a little bit, so I'm not going to go into them right now. One of the other things that you'll need to understand is that you will need to have some sort of authentication with your cluster in order for any of these deployment tools to work. In our case, we have this cube config here, and if I go into home, hidden directory cube, and I actually cat out this file called config, you can see that there's a bunch of certificate secret information, and then you'll actually see that it's just a YAML file that defines all of the different clusters I have authentication material for. Earlier, when we looked at Docker's Edge Kubernetes, I told you that there's a file that these come from, and these contexts are defined in this file I have catted out to my screen here. You don't really need to know what's in this file as much as you just need to know that it exists, and this is effectively your secret file for the cluster. This is what gives you the ability to run command line tools against Kubernetes. So going back to our slides. So that's how you authenticate with Kubernetes. If you installed with Cuba Corn, we will write that file automatically for you so you don't have to deal with it. If you installed with the Heptio Quick Start, there's a little bit of a chore of going and actually getting that file off the server. If you installed with MiniCube, it should have written the file for you. But ultimately, you just need to know that you need that file pointed at the right server with the right TLS authentication material, or you're not going to be able to access your cluster. So that's the first snippet into Kubernetes security. OK, so next slide. So long ago in the before time, I worked for a different company, and I worked really closely with a really group of awesome folks called the Helm team. And I remember them saying that they wanted to be the package manager for Kubernetes. And if you go look, Helm right now is probably the de facto way of installing applications on Kubernetes, although there's now other tools are coming into the space. I think Helm is just the oldest, so that you see a lot more working examples and people who have decided to use Helm. The best way I can think of describing Helm to you is replace the word Helm with apt-get, or yum, or pacman if you're an Arch Linux user like I am. Yeah, Arch Linux, woo. So yeah, from my command line, I would be able to type helm install MySQL. And that would actually pull the MySQL container and install it in my Kubernetes cluster for me. And that's sort of the workflow that Helm gives you. Helm's powerful because you can actually go and define your own applications and Helm install them. And it sort of gives you a framework to build that around. One of the things you need to know about Helm is it's a client-server model, and you need to make sure that that server-client conversation is encrypted, or you can potentially have a vulnerability in your cluster. Furthermore, it introduces an out-of-cluster dependency, meaning it's yet another command line tool you get to download on your laptop to help you Kubernetes. Furthermore, Helm takes the YAML that we will see everywhere in Kubernetes, and it puts another layer of configuration management on top of it. So you're now dependent on using Helm to interpret these config files that you're writing, and you cannot deploy them any other way other than using Helm to parse them. So you're actually creating charts that are only valuable to Helm. And yet, this is even more YAML and even more magic because Helm actually makes you write more YAML files than Kubernetes would make you write in the first place. KSonnet. This is not necessarily a competitor to Helm, but another approach to solving the application deployment process in Kubernetes, which we're about to go through manually in a moment. And this calls itself a configuration manager for Kubernetes. So it's not a package manager like Helm is. The configuration lives in your local repo. And then from the context of your local repo, you are then able to apply various flavors of that configuration to your cluster. The best example I can think of is I'm in a working directory for my application, and I have a set of concerns I wanted to define for dev or for test deployment. And then I have a completely other set of concerns that I wanted to define for production, right? Real authentication keys, maybe actually running on real hardware, things like that. KSonnet allows you to have the two different flavors and switch back and forth between them easily. It's based on JSONet, and that whole environment thing that I just described, Helm can't do that. So that's one of the perks for using KSonnet. Also, Case on it does not have some sort of client-server model. It just runs locally, so it alleviates that potential security hole by running a server in your Kubernetes cluster to track things for you. This is actually pretty common, believe it or not. A lot of people just kind of like use sed or use bash and kind of do this deployment thing on their own. And we're going to look at a deployment concretely in a moment, and you'll understand why you would want to use sed or bash. But the point I'm trying to make here is some people have decided to do this themselves, and in some cases that actually makes sense for you and your team. I'm going to be doing everything very concretely today using the bare minimum of primitives. So that's going to feel very similar to this type of experience. The only thing you need to be aware of with this is it's easy to get trapped here because it'll start working, and then you'll start to paste more and more bash scripts. We've all done this before. Paste bash scripts on top of bash scripts on top of, yeah, he's shaking his head right now because it's a thing that can totally happen. So you need to be aware of that. Also, there's Client Go, which is the Kubernetes official Golang SDK that would allow you to basically build your own deployment tool. And there's other SDKs available as well. There's SDKs for Python, for Java, for JavaScript, for TypeScript, for Ruby. And because of these SDKs, you could potentially write your own tool that solves this problem of getting a container running in Kubernetes for you. As any time you generate your own tooling, you're going to have to support it. But ultimately, at the end of the day, all you're doing is you're sending a TLS and authenticated API request to the Kubernetes server and just telling it where to pull an image from. So it's not impossible to build this on your own. Last but not least, the magic tool that I would like for everybody to download if you don't already have it downloaded. This is 99% of the time what you're going to be reacting with if you're working on Kubernetes. This is called kubectl, or kubecontrol, or kubectl, or kubectl, or whatever you want to call it. But this is sort of the main entry point for observing and interacting with a Kubernetes cluster, and this is what we're going to be using today. What you need to know about it is it reads YAML configuration files, and those YAML configuration files are just called manifests. Oh, here's my pulling an image diagram I was looking for earlier. So anyway, all that is going to be happening when we actually deploy our container to Kubernetes is we have some image registry here. For the example I'm doing, remember I pushed that Python container up to Docker Hub. So you can just imagine Docker Hub right there. There's going to be these components inside of Kubernetes called the scheduler and the controller manager that then will declare how much and how many of these containers to run on which virtual machines. And then each of those VMs have a kubelet that will then actually go and start a container for us. So when you look at the kubelet here, does everybody remember when I did Docker run a moment ago? That's all the kubelet's doing. Just think of a kubelet as just a bash script that just says Docker run. That's a really easy way for you to imagine what's going on here. OK, whoops, sorry, wrong button. OK, so some common image registries, if you want to snap a photo of this to go check out. I'm using Docker Hub. There's one called Quay. Google has one called GCR. Amazon has one called ECR. Microsoft has one. There's a bunch of them out there. It's just a place to store container images. It's not a super critical decision. Deciding on this is mostly which UI you like better and which one feels more natural to you. OK, but because of this, this is why we need CI/CD. Because of this whole Kubernetes is going to pull an image from an image registry, and we're going to need to build that image. That is why you'll always hear, oh, me and my team need to solve this CI/CD concern, because this whole Docker build and this whole makefile stuff that we just went through would be nice to have it automated so that you didn't have to go and do a Docker push every time you wanted to run your container in Kubernetes. So that's why we have this need for CI/CD. I think Bazel, not Bazel, is a really good example because it has a lot of the container building stuff built into it. But there ain't nothing wrong with using Jenkins other than the fact that you're using Jenkins. So what do we need in Kubernetes? OK, this is the first part of the day where we're going to start learning Kubernetes primitives. I'm going to go kind of quick here, but if you get lost or confused, stop me. I really sincerely mean that. Please put your hand up. So the smallest thing in Kubernetes you need to know about is this thing called a pod. A pod effectively is your application. So this whole time we've been talking about building a container. What a pod does is it allows you to run one or more containers. Remember I said earlier everything's a set in Kubernetes? A pod is just one or more containers. But it's the smallest working unit in Kubernetes. It behaves similar to a single virtual machine, meaning that it has shared storage and shared network. So if you define 2 containers in the same pod, they're able to share storage between them, and they're able to network between them. Furthermore, we have these arbitrary strings, like literally they're called labels, but literally it's just key value pairs that can be anything you want. And Kubernetes likes to use these labels to map pods to various things moving forward. What you need to know about pods is the whole point of them is so that they can be scaled up and down. Meaning we have a pod that runs one or more containers, and then we can have multiple instances of that same pod. And that's important for when we start looking at distributing our application horizontally. And usually a pod is an application, aka a microservice. In our case, the Python program that we just built and put into a container is ultimately going to turn into a pod after we deploy it to Kubernetes. A layer above the pod is this thing called a deployment. And a deployment just defines a set of pods. So now we're in the sets of sets department. And this is helpful for scaling our application horizontally. If we had a web application that was receiving a ton of traffic and the web UI was constantly slowing down, we would use the deployment to actually increase the number of pods and then distribute traffic across an even higher number of user interface web UIs and fix that laggy problem that we were seeing earlier. So deployments are sets of sets, and they're important because these are going to be ultimately what define the container image that you're going to be running. In our case, it's going to be that Kris Nova Kubernetes Workshop app we just created a moment ago. Furthermore, deployments are self-healing, meaning if I told the deployment I would like 10 copies of a pod, and one of the pods exited randomly, as it would, because remember our program is sleeping for 1,000 seconds and then exiting, Kubernetes will detect that the container has broken and reschedule it so that we always have 10 copies of it running. Now, because containers are ephemeral, we would actually start a new container. It would be a new system process, but it would be an exact replica of that same container we've created before. So that's a deployment. This is our last one. I'm keeping it simple just to start. This last one is called a service. And a service is a network abstraction for the pods and ultimately for the deployment. You would map a deployment to a service. How you map those things together are those labels we talked about earlier. And we're going to actually look at these primitives, so don't worry if this is confusing and you don't understand where you would define things like a label. I'm about to show you. And those labels are how Kubernetes would say, this service goes with this deployment. So you could say match on label name is equal to Nova, and as long as there is a deployment that had a label called name equal to Nova, those two would match together, and we would be able to define the networking components for our deployment. Effectively, when I think of a service, all I think of is poking a hole in the firewall. All we're really saying here is I would like to control some level of access to my application. And if we were to actually build a web service, we would use this to, like, say, open up port 80 and map that to our pod that we just created. And we'll take a look at doing all that here in a moment. So how do we get there? What are we actually going to run today to get this container that we just built running in Kubernetes? I'm going to use these 2 commands here for kubectl called kubectl run and kubectl expose. The first one, kubectl run, is going to create a deployment, and that deployment will have some subset of pods, each of those pods running the image that I define with the -- image flag, and I'm just going to paste in the image that we've been using, but you can use any old image you want. After the deployment is up and running, I'm going to then expose that application to the broader internet by doing kubectl expose, and I'm going to just simply map port 8080 to target port 8080. And I have an example program that I'll run in a moment that is actually going to be a web service listening on port 8080, and we'll be able to hit that together if we have enough time. OK, so is everybody good on those two commands? And we're going to run them, and we're actually going to look and see what happens. So let's run these in Kubernetes. So to start off, I have the kubectl command line tool downloaded. Show of hands who already has this up and running. OK, if you want to go ahead and type kubectl get pods, you should see that. Show of hands if you can run that command and it works. OK, cool. So I have two aliases that I like to use. The first one is I do alias k is equal to kubectl. And the second one I do alias, I just call it kdump, and I set that to kubectl get all -- all namespaces. The first one just makes my command lines a little bit easier. And the second one is literally like, show me everything that's running in my cluster, which is kind of cool for demos so that you can actually see that we're creating all of these pods and services and deployments that we just talked about. OK, so let's run our application in Kubernetes, and then let's talk about what happened behind the scenes. So to do that, I'm going to type kubectl run. And let me just pull up my command here. The name of the deployment. So this can be any name that we want to call it. Does somebody just want to shout a name out? What? Bob. OK, we're going to run Bob. Kubectl run Bob, and we're going to say -- image, and then we're going to paste in the name of our image here, which is, of course, Kris Nova Kubernetes Workshop app. And we're going to say latest. Remember earlier we tagged that with the latest tag? Deployment apps Bob was created. That's it. My container is now running in Kubernetes. So let's talk about what actually happened, because there's a lot of stuff that just happened. So if I do ktx, which is an alias I have called kubecontext, you can see that I'm actually pointed to this Kubernetes admin at Kubernetes cluster. Now, if I was to go and look in that kubeconfig file, we would actually see that that kubeconfig file is pointing to WK3 master here. I created a new Kubernetes cluster during one of the breaks and just called it WK3 using Cuba Corn. And so that is running in Amazon, and I just interacted with that cluster. So if I do kget pods, remember k is short for kubectl, you can see that I now have one pod running. It's called Bob, and it has this unique hash at the end of it. And every time a pod is restarted, it's going to get a unique hash. And that is sort of like its social security number. To demonstrate some of the resiliency with Kubernetes, before I actually look at the logs for this pod here and we can explore the pod, I just want to show folks what would happen if I delete this pod. So I can delete this pod by doing kubectl delete pod, and then I'm just going to paste that unique name for the pod. What's going to happen? Does anybody want to guess what's going to happen? A new one's going to get created. This controller manager says, I'm supposed to have one container created. I deleted it. Oh, no, there's actually 0 containers running. We're going to go run a new container, and that's called a pod. So now if I do kget pods, you can see that this one was terminated, and this one is our new one as well. So to get logs, we're going to do kubectl logs, the name of our pod. And then just like everybody's done a tail -f before, kubectl takes the same -f command line flag here. And that's going to basically give us our same yes? I'm sorry, what was the question? I'm going to get there in just 1 second. OK. So I wanted to demonstrate a quick thing about the pods. So right now, we're experiencing that same effect of the Python application is running, but because we haven't Control-C'd it, it hasn't actually echoed out to standard out yet. So we can, and we know we've already deleted one of the pods and it was rescheduled. I can actually get the previous pod logs by doing -- previous here. And you can actually see not found. Let's try this again. Kubectl logs this -- previous. Not found. Sorry, what was that? Oh, thanks. See if that works. Nope. I don't know why that's not working. That usually wants to work, and you can get the previous logs. Anyway, I'll think about that, and if somebody else wants to shout something out, I can try it. But the point I was trying to make was you would be able to see the rock climbing is the best sport in the world text in the previous pod there. But to answer your question concretely, how would you decommission your app since Kubernetes is just continually rerunning our container over and over again? We would interact with the deployment object. So if I do kubectl get pods, I see the pods. But remember, the pods are a reflection of what the deployment has defined. So in order for me to see the deployment, I would do kubectl get deploy, which is short for deployment. And you can see that I have one here called Bob. Now this is where the YAML comes in. I can actually edit this deployment. And what that would look like would be me doing kubectl edit, the name of our deployment, kubectl edit deploy, the name of our deployment, Bob. And that's going to open up in our favorite text editor, Emacs here. And you'll see our first YAML, which I like to pat myself on the back for not getting into YAML until 2.5 hours into this thing. And if you come down, you see replicas equal to 1. If I change this replicas equal to 1,000, and I run kubectl get pods, you can see that Kubernetes has now started 1,000 containers distributed across one virtual machine in Amazon. And if I had 1,000 virtual machines in Amazon, who can guess what the math would be? 1 container per machine. And if I had 500, if I cut that in half, 2 containers per machine. If I had 250, 4 containers per machine. And Kubernetes distributes the load horizontally. And so this is exciting because now I have basically started 1,000 Python processes on this, this cloud computer. And I did that all from the command line here. But also, I can interact with this programmatically. So if me and my team wanted to solve any problems related around Kubernetes programmatically, there are now these primitives in place. And this is where we start to really see this kernel concept appear. I just demonstrated how to create a container and run it in Kubernetes, and then look at 1,000 copies of it using kubectl. But if you wanted to write tooling, or if there was a piece of tooling in open source, that tool would not really care about where your cluster is running, right? It wouldn't matter if we were running in MiniCube or Amazon. We would still be able to issue the exact same kubectl command and get the same output. So we're starting to see that we can start to build on top of Kubernetes. To quote one of my colleagues, Joe, Kubernetes is a platform. It gives you primitives in which you can build on top of. And last but not least, let's look at the service here. So we can do kubectl get service, and we can actually see that we now have this service called Kubernetes. And if we echo that service out, we can do kubectl get service, the name of the service, output equal to YAML. And you can actually see that it's going to echo that YAML out here to standard out on my local computer. And if you scroll down, you'll see, remember we talked about labels beforehand. And you can scroll down and see that we are actually exposing port 443, protocol TCP, and we're mapping that to the target port 443. Down here, the type is important. Right now we're running cluster IP, which is a bad way of saying this is only accessible to other applications running in Kubernetes. But if I wanted to change this to type equal load balancer, Kubernetes would actually go and create a load balancer in Amazon and point that load balancer to the node or nodes that this application is running on and distribute traffic horizontally across all of these 1,000 pods I just created. Does that make sense to everyone? Question? Say again? OK, so the question is, can you do that in the VM itself without incurring the cost of a load balancer? And that's where we get into this new type of primitive, which the primitives we've looked at so far are pod services and deployments. There's this other one called ingress that allows for you to bring your own ingress controller to the table, which is where you could do things like using Nginx to actually distribute it so that you're not actually paying for a load balancer proper. The takeaway here with all of the Kubernetes resources, we've looked at 3 today. Every Kubernetes resource is effectively an object. This is one implementation of the service object, right? So you see up here at the top, it says kind is equal to service. That is a Kubernetes service object. We also have pods, and we also have deployments, which we defined a moment ago. But I think there's 32, I want to say, total Kubernetes resources, and you can actually build your own as well if you wanted to. So the takeaway here is we looked at deployments, we looked at pods, we looked at services. Those are the first basic 3 that you're going to need to familiarize yourself with. But you need to go in and actually learn a handful of these if you really want to master Kubernetes. And that's where things like ingress and secret management and some of the other cool features of Kubernetes come into play. And there's actually a link a few slides down in my slides that take you to the API documentation that calls out all of the cool different objects there are in Kubernetes. If anybody wants to see one, I'm happy to demo one here live as well. So anyway, let's try to get a web service up and running in Kubernetes and actually send an HTTP request to that web service and get some data back. And we can do all of that pretty quickly now that we have the primitives in place to push a container. We have the container registry set up. And I can just rewrite over Kris Nova Kubernetes app latest with this new program that I'm about to run for you right now. And then all we have to do is just change the service type, and we'll be able to resolve that. So the last little demo we have here, if you go back to the repo, here in the last directory in web services, you see we have this directory called app. And this is a pre-built Go program that I wrote beforehand that basically is a simple HTTP web server. So if you come in and you actually look at what's going on in the Go program, it's OK if you don't write Go. It's not the end of the world. All you need to know is it's listening on root, the root directory here. And it's going to echo out Alpine Trad is the best sport in the world if you send an HTTP GET request to root. And that's listening on port 8080. So in order for me to build that, I go back into the repo that I have checked out here, Heptio, Kubernetes Workshop. And then I'm going to go into this last directory, web services, go into app. And using the make file, I'm going to do make container push. So you can see how quickly this is actually going to go in an update. So the make file in this example is basically serving as my Kubernetes CI/CD deployment tool. I didn't have to type docker build because I hid all that away in the make file. And I didn't have to type docker push because I also hid that away in the make file. And there's a lot of tools out there that make this experience richer. There's a tool called Draft from Microsoft that will actually watch your directory. And as you make changes and you save the file, it will rebuild the container and repush it kind of behind the scenes. So you're always getting this real-time container push. So it's not quite as involved as it once was once you kind of get it right. Remember, we talked about technical investment, an hour talking about containers, and then I just did everything in like a second here. So that's pretty exciting. So now that that container is pushed, we can actually go and we can restart the pods in Kubernetes, and it should pull this new container image that we just pushed down. And how are we going to restart the pods in Kubernetes? Any idea? Kubectl, then what? We're going to delete them, just like we did a moment ago. OK, so my Kubernetes cluster is actually kind of overloaded right now. So let me scale these 1,000 applications back down, just because I'm about to break my cluster. So the shorthand way of doing that is kubectl scale deploy bob -- replica is equal to, let's just do replica is equal to 2. And the Kubernetes layer of software that's running on my cluster in Amazon is now busy deleting all of these containers it was just trying to start in the background. And so if I do a kubectl git pods, again, you can see as soon as it wants to respond, somewhere up in here of this 1,000 that I just created, we should be terminating. It must be mixed in there right now. But it should start terminating those pods pretty quickly. And the ones that are marked pending are no longer going to be pending. So it's just busy reconciling that state right now. And actually, I'm going to just go ahead and set replicas equal to 0. And then that's a good example of how to decommission your app to answer that question from earlier. And then, of course, if I wanted to delete the deployment entirely, I could do that as well. So we're waiting for that to scale down. Does anybody have any questions so far? I'm moving pretty fast here. No questions? Yes, question? What happens if you scale beyond the capacity of a VM? Excellent question. So this is where tools like the Cluster API would come in and give you some sort of promise that would say, we would be able to detect that and then potentially create another virtual machine for you. That tooling doesn't exist yet. So right now, it's up to you and your team to have some sort of awareness of your current workload on your cluster. I think there is this command, kubectl top. And you can do kubectl top node. Uh-oh, I might have already broken my cluster. Nope, they're terminating. But the top command should give you some meta information about where your node currently is. It's really hard to put a cluster into deadlock, so to speak, where you've out-scheduled the capacity of the cluster because the Kubernetes layer of software is already running, right? So I've done it before. It's pretty hard. You basically have to get a cluster pretty much at capacity and then kill some of the core components of Kubernetes, which are also running in containers. And then the scheduler would try to reschedule your application before it tried to reschedule those other ones and officially render that node unusable. It is possible, but not very common. Any other questions? The deploy? Just, you want me to type that? OK. Do you want me to get it, or? Do you want to see the YAML again? Yep, and that's what you see here. Desired, current, up-to-date, available. Another interesting part of Kubernetes is there's actually an object called node, or nodes, rather. These represent the virtual machines themselves, right? So you can see here these are both in status of ready, one of which is in the master role and the other one is in no role, which basically means it's working as a workhorse. Because we only have one node, Kubernetes is only going to distribute our load across that one virtual machine. But in theory, we could have as many of these as our data center allowed, and we would be able to distribute our load horizontally across all of them. So you can also get a status of your node infrastructure through the node object as well. So anyway, if we finally do a kubectl git pods, excuse me, no resources are found. We can repeat this last scale command, and we'll do replicas equal to 2. And we can do kubectl, or I'll just do K for short, git pods, and poof, we're now back to running 2 containers. Except for this time, instead of running the Python container we looked at earlier, I'm now running this Go program that I just built and pushed up to Docker Hub a moment ago. So in our program, if we look at it, you can see that it echoes out this line here that says serving ... and then it starts the server. So we should be able to actually get our logs this time, because we're not going to have that same Python weird thing going on with standard out, by kubectl logs, the name of the pod, and then we'll do -f again. And you can now, of course, see that our logs are working as expected, and we have serving ... So let's try to hit this API endpoint. So we're going to edit the service. Remember, the service is sort of the network layer, and we map a service to a deployment, which effectively maps it to a pod. So in order to edit the service, we're going to do kubectl edit service. I think it's just called Bob. What is the name of this service? So with kubectl, you see how I just typed svc here? All of the resources have a shorthand. So this is actually a valid command here. Kget svc is short for kubectl get services. So kget svc, oh, it's because I haven't done the expose yet. So let's do this expose command that we talked about earlier. So we're going to do kexpose, the name of our deployment, which is Bob. Let me make sure I get this is the command we're running here. And then we're going to say port 8080 and target port 8080. -- port 8080 -- target. I think it's target - port. Let's make sure that's right, though. Yes, it is. Target - port 8080. So you can see how already we're getting interesting mappings with our different ports that our application could be listening on. And it's a lot to keep track of, which is why having some sort of deployment management tool like Helm or Case on it simplifies this whole thing that I'm doing here. Kexpose. You have to tell it what we want to expose, which of course is a deployment. So now if we get our services, we should see we now have two services. The main one for Kubernetes, and we have this other one here called Bob. So I actually want to change something in the Bob service. And so how we're going to change that is we're going to do the edit command again. So kedit, the type of our resource, which is service, and then the name of our resource, which is Bob. That's going to pull it up in our text editor of choice. And if I scroll down here to the bottom, this is actually declarative in nature. And this is one of the big value adds of Kubernetes is just by changing the configuration here and saving this, we're then going to resend this back up to the Kubernetes API server. The API server is going to stick this information in etcd. Those controllers that we talked, remember the robot arm from way long ago? Those controllers are actually going to read all of this state, and then it's going to say, oh, I have not configured this service correctly. I actually need to go and make this adjustment. So changing the type from cluster IP to load balancer, this is where things get exciting. And we still want port 8080 and port 8080 here, is going to actually tell Kubernetes to go and create an ELB load balancer in Amazon for us. And this is for the first time. We're actually watching a layer of software mutate underlying infrastructure based on some declarative model, which what just happened is one of the huge value adds of Kubernetes is you don't really have to care how things are solved. You just have to care that they do get solved. And so now if I come into my Amazon console and I come down here to load balancers, you can see that we actually have magically created one load balancer. And if you look here at instances, and if you've ever looked at a Kubernetes load balancer before, you'll be able to come in and see that it is in fact listening on port 8080, and it's pointed to the correct node. And we're just waiting for it to come up right now. So yeah, it's listening here on port 8080, which is exciting. So how we get the public resolvable URL for this web service is we do a kubectl get service. I think it's O wide. So the -O stands for output. And then you can do output JSON, output YAML. In this case, I'm going to do output wide, and that's just going to make sure it echoes everything out to the screen. The reason I do that is because I know that this string here was going to be pretty long to get the actual load balancer a name out of the output here. And if I actually like zoomed out, like shrunk this, and we could like scale my terminal window here, and it would actually be pretty if I had a wide enough screen, but I just don't. So anyway, this string is actually going to match this string here. And that's just a URL that you can go and type in. And if all works, you should be able to go to that endpoint. Sorry? Oh, thank you. Port 8080. On port 8080, and poof, we have created a web service running in Kubernetes in Amazon that is now publicly accessible. So from here, we could do a lot of cool things. We could go and we could create a DNS entry, maybe in Route 53. Let's do that right now, actually. This is my work account, so I don't know if I have, yeah, I have tgicates.com. We could go to tgicates.com, and we could just actually put in, where is it at? Create record set. We'll just do a basic C name, and we want it to go to that A record. So anyway, while we're waiting for that to propagate, we'll go to app.tgicates.com. Thank you. OK, so we're waiting for that to propagate. You can just begin to see all the different ways you could write software, stick it in a container, run it in Kubernetes, and then you can, using Kubernetes primitives, you could actually design a system for you and your team that makes sense. So the whole point is that we have all of these standardized objects, like services, like deployments, like pods, that define the shape of what action we want to take in the cloud. And then Kubernetes is just the software that just goes and just makes those changes happen for us. So I chose to build a web service because I feel like most of us can resonate with a web service. But if you and your team had a data pipeline that was consisting of multiple applications, you would probably have multiple deployments. To give you an example of all the types of resources that are actually running to make Kubernetes happy, I can run this kdump command that I created earlier. And you'll actually be able to see there is a ton happening behind the scenes here in Kubernetes that actually brings our cluster to life and makes all of this stuff work. To kind of go over it without going into a ton of detail, up here at the top, we have all of these pods running. Here are our Bob pods that we created earlier. We also have this tool called Calico, which solves networking concerns for us. We have the etcd storage. Remember, we talked about it needs a data server to store all this. It has the Kubernetes API server itself is running in a container inside of Kubernetes. And you and your team could build out a system that would have a completely different output than this would on top of all of these other existing tools. And that's the big value of Kubernetes. So we have 15 minutes left. I want to make sure I show folks stuff that's meaningful to them. So we have an application. We have a container registry. We have Kubernetes up and running. Who wants to see something, anything inside of Kubernetes that they have questions about? OK, what's up? I'll get to you in a second. Kubectl Git service. Yep. Yes. OK. So all he pointed out was now we have the external IP address column, which was not there before. And the reason we have that is because we changed the type to load balancer. I can barely hear you. I'm sorry. Correct. He said with cluster IP, I would only be able to access my service inside of the Kubernetes cluster. That is correct. So that would be if we had another pod or another deployment running in Kubernetes, we would be able to access that, but we wouldn't be able to gain access to it publicly like we just did here externally. Yes, and I want to talk about namespaces in a second, so we're going to get there, I promise. Excellent question. The question was, if you scale a web server and then go to the website, what happens? So let's do that. So remember our scale command earlier, replicas equal to 2? Let's do 50. We'll keep it kind of small. So we have replicas equal to 50. Because we have one node in Kubernetes, the load balancer, the ELB, is only pointed to that one node. Otherwise, there's a layer of software called the cloud controller that reads information from the Kubernetes scheduler that would then make adjustments and point the load balancer across whichever nodes were actually running those containers. So when you go and you refresh the page here, you're actually probably getting a different container each time. There's a tool that we have at Heptio called Heptio Gimbal that if you use this more advanced sort of service object called ingress, it allows you to do cool things like say, I want 50% of traffic here and 50% of traffic there, 20% here, 80% there. It allows you to even spread it across multiple Kubernetes clusters as well. But right now in this basic example, it just does everything basic. I think it's round robin style load balancing. Other question? Yes, you. Yes, ingress and egress controllers. I don't know if we have enough time to do one, but if you want, I can do a demo for you afterwards. But the basic thing you need to know about ingress and egress controllers are, and I have a slide on this. I guess I have like closing slides here I wanted to go through. We can do those in the next few minutes. So ingress takes it a step further. So the whole point of ingress is it's able to map arbitrary endpoints. Like here we have /this, which would be that A name we pasted into the URL. And right now we're hitting root. If we wanted to /this, we can map it to some arbitrary deployment. But we could also optionally map /that to a completely other deployment. So ingress gives us this ability to have like, maybe we have one container that all it does is it solves logging into our service, right? And then that's on the /auth endpoint. And then after you're authenticated and you have a token, if you hit another directory, it might actually run a completely different piece of software. And ingress allows you to make logical mappings for your application so that you can really start to pull your application apart into this microservice-y style architecture. As far as an ingress controller goes, remember the robot arm from earlier? An ingress controller takes a tool like Nginx, or we have a tool called Contour that's built on Envoy that does some really cool networky things. And it reads whatever you declare in Kubernetes and then goes and actually makes that so. So remember we were able to edit the service, and there was some controller that actually went and made the change in Amazon after we edited the service. The same with ingress. In order for ingress to work, you would need an ingress controller. Kubernetes, by design, just doesn't ship with an ingress controller, whereas it does ship with controllers for services and pods and deployments and everything else. A really simple ingress controller is the Nginx one. And the kind of thing you need to know about it is once it's installed, you can just edit ingress just like we did with the other primitives, and the controller will actually go and reconcile that, and you shouldn't really have to touch it after you install it once. Excellent question. The question was, if a pod has multiple containers, does each container have an IP or does the pod have an IP? So the pod will get a local IP address. The containers can talk to each other on localhost. So a lot of folks, I'm going to kind of digress here while we're on the topic. A lot of folks have heard of this new hotness called service mesh. And all you need to know about service mesh is that it basically runs this pattern called a sidecar pattern, which basically says, I'm going to run somebody else's pod next to somebody else's container next to my container in the same pod, and then that sidecar container is going to handle things like giving us observability into the network. Maybe it'll handle things like authentication. And that way, my application only has to just hit localhost, and it can just say, hey, localhost, I want a secret, and this other container is responsible for actually returning a secret for them. And that sidecar pattern creates what we call a service mesh. And that's where we get into that whole hotness. Yes? Kubernetes namespace. I really want to get into this, because this is a fundamental part of Kubernetes. It's pretty easy to grok, I feel like. I can do kubectl get namespaces. And you can see we have 3. We have default, which is the one that we've been using this whole time implicitly. You have kube public, and you have kube system. Default is like the default one. And if I actually ran kubectl, remember we've done git pods, and you can see that we have these, 50 some odd pods that have been running. If I do kubectl get pods -- namespace kube system, completely different output, because these pods are running in a different namespace. And all a namespace does is it allows you to logically separate various parts of you and your team's application. It's an imaginary construct, but it's a very powerful construct, because by default, pods running in one namespace don't have access to pods running in another namespace. But you can optionally plug those two together. So namespaces give you a way to segregate your application and draw boundaries around them, which is another great segue into this concept called RBAC, role-based access control. And all RBAC does is it gives you, it's another Kubernetes primitive. You could edit it in the same way we've done a kubectl edit and kubectl get with everything else. And all it does is it allows you to have various users and roles and policies that can do certain things in your cluster. The simplest way to wrap your brain around this is to say like we had 2 namespaces here. Kubectl create namespace accounting, and kubectl create namespace marketing. So at my company, the accountants have some software I need to run for them, and the marketing folks also have some software I need to run for them. But let's say that we have this new hybrid role where we have the new intern who's auditing both accounting and marketing. We would give our new intern, give him a name, an RBAC policy that says you can access both accounting and marketing. But we might only give access to the Kubernetes cluster for accounting to the folks in the accounting department. And then they would only be able to create pods and deployments in their namespace. Namespaces just give you that logical boundary and allow you to separate things as an operator. One of the reasons that we didn't really see namespaces until now is because by default, everything just gets installed into the default namespace unless you say otherwise. Any other questions on namespaces? OK. We have 5 minutes. I want to make sure this is valuable. More questions? I think that's what folks are getting the most value out of. Yeah? So I think I heard your question, but let me just play it back to you to make sure. Running multiple Docker containers, you would give access based on the namespace? Right. So yeah, that's a personal choice that you as an application architect would need to make. So the question was, if you have different applications, do you always want to run them in a different namespace? If I would say the rule that I adhere to is if they are solving independent concerns, like if they're 2 completely standalone applications that have nothing to do with each other, it's good practice to run them in a different namespace. But in some cases, you'll notice that like a single data pipeline is actually composed of 12 or 13 smaller applications, and this is the microservice model. We obviously want all of those smaller bits running in the same namespace so they can interact with each other and do what they need to do to build a full-fledged data pipeline. And then, of course, there are objects in Kubernetes like services, like deployments, like pods that all can be in different namespaces. So we could do what we just did with getting pods in a different namespace with services and so on. Question here.
So is RBAC actually a native function of Kubernetes?
Yes.
Okay. So following up to that.
Sure.
Is it just limited to namespaces? Excuse me. Is it just limited to namespaces, or can it be more granular? Can I restrict access to a specific pod? So yeah, you can control deployment, but you can't start a new pod or whatever.
Sure. So the question was, is RBAC a first-class citizen in Kubernetes? My answer was yes. And the second one, does RBAC get more granular than that? And the answer is also yes. When you define an RBAC rule, you can actually go in and define all of the different types of resources, and you can say all the different actions that a certain person or a certain user or client could use. A really great example is, let's grant access to a namespace. Let's allow pods, deployment services, all of the Kubernetes resources that they need. Let's give it read-only. Let's say that they can list and they can get on those resources, but we're not going to give them write or edit, right? So you can get more granular than just granting access to a full namespace. And then there's a good hour-long RBAC discussion that we can go into at a different talk at a different time. Any other questions? Anybody want to see anything else? Oh, sorry, question here, yeah? I can't hear you at all, I'm sorry. Okay. Okay, so the question was, oh, this is such a great segue. This is all for you, Phil. The question was, if I was running in a data center and I think I heard wanted to set up some sort of network proxy, how would I write a controller to do that? So Kubernetes has this really cool thing called CRDs. A CRD is basically a build your own Kubernetes object. So I can do kgit CRD. And you can see, as soon as my cluster wants to respond, no resources are found. But you can optionally create a CRD to be any object shape you want. If you can write a definition for this object in YAML or in Go, we can create a CRD for it. And then we can optionally have a controller that would read that definition and actually enforce that state. If you wanted to do something like create a homegrown proxy service in a data center, you might have a proxy CRD and then have a custom piece of software that is smart enough to read the definition that you would define in the database and then actually go and reconcile that state by setting up whatever a proxy means to you and your team, right? The segue here is tomorrow afternoon, my co-maintainer over here, Phil Whitrock, is giving a lovely presentation on Cube Builder, which is a framework that actually does what I just described. It makes it super easy for you. So if you want to learn about building custom controllers in Kubernetes, this will probably give you all you need to actually probably get started right away with Cube Builder and building CRDs in Kubernetes. We use it in the cluster API, thanks to actually a PR from P. Whitrock over here. And we're all very grateful that we're finally able to build it. So custom resource definition and custom resources is the answer there. And I think we're out of time, so you're not going to offend me if you want to get up and leave. I'm going to keep answering questions if folks have them. But thank you all for coming. It's been great. Question?